Hey there guys, welcome to this video. My name is Pushpinder Gill, and in this video we are going to be talking about collinear vectors, right? Also we're going to be talking about unit vectors. So we're going to be talking about both of them. So first of all, let's go ahead and get started. So first of all, I'm actually going to talk about unit vectors. What do you mean by unit vectors? Unit vectors are the vectors which have a magnitude of 1. So unit vectors have magnitude of 1, and they can have any direction. Two classic examples that I will give you would be vector I with 1 and 0 and vector j with 0 and 1. So geometrically they actually are like this. So this is vector I with 1 and 0, right? And this is vector j with 0 and 1. So these are the two unit vectors which are there. But you know what? Unit vectors can actually exist in infinite number of ways. Now how is that? So what you can do is you can actually convert any vector into its unit vector. So how is that possible? Let me say, for example, if you have a vector, let's suppose vector v, it's 4 and 3. So if vector v is 4 and 3, that means this is 4 and this is 3. That means this is your vector v, which is 4 and 3. Now if you kind of join this here, this is actually equal to 3 and this is actually equal to 4. And if you use Pythagoras theorem, the r value would actually be equal to square root 4 square plus 3 square, which will actually be equal to square root of 16 plus 9, which would be equal to 25. Square root, that is 5. That means this is going to be 5. Now what I need to do is I need to convert this vector with the same slope, that means with the same theta here. I need to convert the vector with the same angle. However, I need to convert it to a magnitude of 1. Now how to do that? Now if I want to convert it to magnitude of 1, all I need to do is that I need to keep the same. What I can do is I can actually divide this 3 by 5 and divide this 4 by 5. Basically divide this by this hypotenuse here. Now why do I do that? Because if you try to find the resultant value here, what you will get? You will get 3 over 5 whole square plus 4 over 5 whole square, which will actually be equal to square root of 9 plus 16 over 25, which will actually give you square root of 25 over 25, which will give you a 1. That means now this vector has a magnitude of 1 and it has the same direction as the earlier vector. That means what we have done is we've actually converted this vector into its unit vector. So the direction of this vector and a unit vector u, so unit vector u is going to be 3 by 5 and 4 by 5. So that means a unit vector u has a magnitude of 1 and has the same direction as this vector. So if I want to say, let's say for example, I have a vector, let's say a, this is 6 and this is 8. I want to convert this into a unit vector. I want to convert the magnitude to 1 by keeping the direction same. What I can do is I can actually divide 6 by square root of 6 square plus 8 square. I can divide 8 by square root of 6 square plus 8 square. Now why do I do that? Because if I have a vector in which this is 8 and this is 6, this is actually equal to square root of 8 square plus 6 square. If I divide both of them by this by square root 8 square plus 6 square, this by square root 8 square plus 6 square, and this by square root 8 square plus 6 square, as you can see, this becomes 1 and this becomes our unit vector. So this is how you actually convert a vector into its unit vector. So I hope you're able to understand this point over here, guys. Thank you very much for watching this video. In the next video, we're going to be talking about collinear vectors, right? So thank you very much, and I'll see you in the next one.